Hi, welcome to the second part of the probabilistic programming session on message passing. In the previous part, we looked at a Bernoulli beta model corresponding to the situation where you're a company, you want to interview people that come by. You're going to ask them questions, they're going to get those questions right or wrong, and you have some prior expectation of their skill level. In this second part, we'll be changing the type of question that you're going to ask the interviewee. You're not going to ask something that gives you a right or wrong answer. You're going to ask something that they can get a particular score on. And to be precise, they can either score 0 points, 1 point, or 2 points on these score questions. So this changes the model. So we again still have two outcome variables, and you'll see below that again this particular setup translates well into, or generalizes well into any number of questions that you can ask your interviewees. The only change occurs in that the outcome variables x1, x2 are not Bernoulli distributions, they are categorical distributions. And so the skill level is no longer a single parameter that indicates whether this person will get a right answer on this score question, but what the probability is that he or she gets a particular score for that question. And what you want to hire people that have a high probability of getting the largest score. So if we look at the generative model, that is a joint distribution p of x1, x2, theta that factorizes into p of x1 given theta times p of x2 given theta times p of theta. Exactly the same as before, but now the Bernoulli likelihoods have become categorical likelihoods, and the prior has gone from a beta prior to a Dirichlet prior. And so the beta prior has, it's a single number, a scalar, parameterized by two shape parameters, a and b, or alpha and beta. And the Dirichlet distribution is a distribution over proportions. So they are, it's going to output a vector that sums to 1. And that vector is the parameter for the categorical distribution, and yeah, you want, for instance, a parameter vector where someone has a high probability of getting the highest score, and then a good probability of obtaining the second highest score, and then a low probability of getting 0 points. So the Dirichlet distribution outputs a vector that sums to 1, and itself is parameterized by a vector of something called concentration parameters. They're not shown here because we have clamped them, and concentration parameters tell you a bit about where the prior probability concentrates in a particular region, and that concentration, we'll get more into that later on with the visualizations. So we're going to build that model in Formulab. Again, we'll start with a factor graph assignment, or a definition. We're going to add the prior, which is theta is now distributed as a Dirichlet distribution, and then these are the concentration parameters. So there are as many concentration parameters as there are outcomes in the categorical or the outcome variables. And so the concentration parameters tell you what the probability is of getting a certain score before you've observed the data. So we're going to put a prior on this situation where with high probability, or relatively high probability, that the participant or the interviewee gets a score of 1, then a score of 2, and then a score of 0. Again, we're going to call this prior f of a, the first factor node. We have two likelihood nodes again, this time defined as categoricals, fb and fc, and they are, we're going to tell Formulab that they are going to be observed. So again, we have the same generated graph, and then if we ask Formulab to generate an algorithm, it's going to give us the same message computation schedule. So again, two likelihood nodes, fb and fc, with messages 2 and 3, and they are combined at the equality node into a message 4, and then the prior sends out a message as well, and then the multiplication of message 1 and 4 produces the marginal for theta. So this time when we execute the algorithm, we're not going to feed the exact score to Formulab. So we don't say that x1, the observed outcome, is a score of 1 or a score of 2. We're going to use a 1-hot encoding. If you want to know more about one-hot encoding, that's described in Bert's lectures on discrete distributions. So, and I encourage you to look over there. So suppose that on the first question you got a score of 1. That translates into a one-hot encoding of 0, 1, 0. And suppose that for the second question you got a score of 2, which translates into a 0, 0, 1 outcome. So if you visualize all of the messages, we'll use step theta to update the marginal and to populate the marginal and message data structures. So that gives you the following messages. We're not going to compute these by hand, but I encourage you to try this out yourself. The Dirichlet distribution is as easy to work with as the beta distribution. But what's more important here is that you develop an intuition for what the Dirichlet distribution is and what it means for things to concentrate. So visualizing the Dirichlet distribution is a bit tricky. It is a distribution defined over vectors that sum to 1, so proportions. But that means that so normally if it would be a distribution over vectors of certain dimensionality, then you cannot really visualize that for large for high dimensional spaces. The great thing about this Dirichlet distribution is that because it has to sum to 1, it is constrained to lie on this particular triangle here in three-dimensional space. So if the number of outcomes is 3 or less, then you can still visualize the Dirichlet distribution by taking this triangle and then projecting that onto 2D space. You're flattening that triangle, and then we're going to show the density by the concentration on that triangle. Right, so that produces this visualization. You should read this as follows. Everything that's blue has a low probability, and then as you get into red, so it changes through these colors, you're going to get a higher probability. So, and what we then see is that the probability mass concentrates in this particular region, and then drops off in each direction. So this is the message from the prior Dirichlet with concentration parameters 1, 3, 2, and so you see that it's it's almost concentrating in this particular corner of the triangle, but not entirely. So I encourage you to read through the lecture notes in your own pace. It contains a lot of information on Julia and Python and visualization, and I think it will help you understand what is happening in code as well. So here we have the visualization of the message from the equality node, which has concentration parameters 1, 2, 2. And you can see that's symmetric according to this base, and then deviates in this base. So that's the first direction. This is a very wide. It doesn't concentrate a lot. It's sort of a wide distribution, a lot of variance. If you then look at the marginal, which is the product of the message from the equality node and the message from the prior coming together to produce that posterior for theta, you see that it has higher concentration parameters, and it really is concentrating in this particular region of the this triangle. So it's concentrating in this particular region where we are with high probability we're going to draw a number that is 0.7 on its first. It's harder to interpret these things because it's a three-dimensional thing projected onto 2 dimensions. But we are expecting here numbers that correspond to, with largest probability you're going to get a score of 1, with somewhat less probability you're going to get a score of 2, and with the least amount of probability you're going to get a score of 0. Yes, so I encourage you to try out these, this model yourself. So the whole point of the probabilistic programming sessions is that you get a chance to get your hands dirty with these models. In this case, with message passing on this Categorical-Dirichlet model. So one way to do that is by changing the prior parameters here. So what if the company expects you to get your score question wrong? Or what if they expect you to get, you always get a high score? Then you would change this into maybe something like this. What if you got a 2 high scores? Sorry. What if you got 2 high scores, or actually 2 low scores? What happens then to each of the messages and to the eventual marginal? Right, so you can play by this, evaluate all of these cells, and you're going to get a different answer. And I want you to try this out to develop an intuition for categorical likelihoods and Dirichlet priors. Right, so we'll move on to the third part in the next video.